Hello and welcome to the Stars of Physics. In this video, we shall see Trigonometry the easy way part 2. Here, I will show you a method to remember 45 plus trigonometric formulae or identities. And also, I will show you how to prove most of these formulas by using simple trick. So first of all, we have to consider a super hexagon. So this is the hexagon. It is having 6 vertices. Then we know that tan theta is sin theta upon cos theta. So write down tan theta at this vertex. Then go in a clockwise direction and write down sin theta next to this in the clockwise direction. And next to that, write down cosine of theta at the next vertex. So we got this. So we got tan theta as a ratio of sin theta and cos theta. So tan theta, then we have written in a clockwise direction sin theta, and then we have written in a clockwise direction cos theta. Now we know that reciprocal of tan theta is cot theta. So at the opposite vertex of tan theta, we will write down cot of theta. Then reciprocal of sin theta is cosec theta. So at the opposite vertex of sin theta, we will write down cosec theta, and reciprocal of cos theta is sec theta. Therefore, at the opposite vertex of cos theta, we will write down sec theta. So this is our super hexagon. Now using this super hexagon, we shall remember different trigonometric identities. So here we have the super hexagon. I will write down 1 in the middle or center of this. So this is 1 here. Then tan theta and cot theta at the opposite, they are at the opposite vertices. Therefore, the product of tan theta into cot theta is 1. Similarly, opposite to tan theta we have cot theta, and opposite to cot theta we have tan theta. Therefore, they are reciprocals of each other. So tan theta is 1 upon cot theta and cot of theta is 1 upon tan theta. In the similar way, sin theta and cosec, for sin theta and cosec theta we have sin theta into cosec theta equal to 1. So also we have sin theta as 1 upon cosec theta and cosec theta as 1 upon sin theta. And also opposite to the cos theta we have here sec theta, product of cos theta and sec theta, that is cos theta into sec theta is 1 and cos of theta is equal to 1 upon sec theta, and sec of theta is 1 upon cosine of theta. Now we shall see some more trigonometric identities. So here we have to move in a clockwise direction. So how the clock moves, if we move in that direction, we call it as a clockwise direction. So I will start here tan theta and will go to the next one, that is sin theta, and the next one is cos theta. Then what we have here is tan theta is nothing but sin theta divided by cos of theta. In the similar way, we have sin theta as cos theta divided by cot of theta. Then cos theta is cot theta divided by cosec theta. And cot of theta is cosec theta divided by sec theta. Then cosec theta is sec theta divided by tan theta. And sec theta is tan theta divided by sin theta. So like this, we got these different trigonometric identities here. Now if we move in an anti-clockwise direction, then also we can get some trigonometric identities here. So what we have here, tan theta is nothing but sec theta divided by the next one, that is cosec theta. And in the similar way, we have sec theta as cosec theta divided by cot theta. Then cosec theta is cot theta divided by cos theta. Then cot theta is cos theta divided by sin theta. Then cos theta is sin theta divided by tan theta, and sin theta is tan theta divided by sec theta. Now furthermore trigonometric identities we are going to see here. So we have tan theta multiplied by cos theta will be nothing but sin theta, which is in between these two. So we have tan theta into cos theta as sin theta. Similarly, we have sin theta into cot theta as cos theta. Then cos theta multiplied by cosec theta is cot theta. Then cot theta multiplied by sec theta is cosec theta. Then cosec theta multiplied by tan theta is sec theta. And sec theta multiplied by sin theta is tan theta. Now we shall see further more trigonometric identities here. So we have this super hexagon here. So consider these red colored three triangles here, and we will move here in a clockwise direction. Now see here, this is moving in the clockwise direction. Then we have what? Square of this plus square of this is equal to square of this. Okay, so that means sine squared theta plus cos squared theta is equal to 1 square. Now 1 square is 1 only, so we will write down it as sine squared theta plus cos squared theta is equal to 1. In the similar way, we have here 1 plus cot squared theta is equal to cosec squared theta, and tan squared theta plus 1 is equal to sec squared theta. Now if we move in anti-clockwise direction, then also we get some trigonometric identities. These are, say, I will consider this 1 in the center first term. And now remember here, while moving in an anti-clockwise direction, the second term we have to subtract. So we have 1 square minus cos squared theta is equal to sine squared theta. So 1 square is 1 only, so we can say that 1 minus cos squared theta is sine squared theta. In the similar way, we have cosec squared theta minus cot squared theta is equal to 1, and sec squared theta minus 1 is equal to tan squared theta. Now to prove all these above relations, we can prove them in a different ways. One of the easy way is to use the SOH CAH TOA, which we have seen in our previous lecture, that sine theta is opposite divided by hypotenuse, cos theta is adjacent divided by hypotenuse, tan theta is opposite divided by adjacent. And these are the reciprocals, that is cosec theta is 1 upon sine theta, sec theta is 1 upon cos theta, cot theta is 1 upon tan theta. Then in whichever relation you have to put these values over there in the LHS of that relation and also in the RHS of that relation, and you have to use simple techniques in most of the cases Pythagoras theorem to simplify that, and finally you will get LHS equal to RHS to prove all the above identities. Now there are further identities, they are called as the co-function identities. Now consider this horizontal line which is having an arrow on both the sides. So what it signifies is that sine of 90 minus theta is cos theta, and similarly cos of 90 minus theta is sine theta. Now similarly we have tan of 90 minus theta as cot theta and cot of 90 minus theta as tan theta, and sec of 90 minus theta as cosec theta and cosec of 90 minus theta as sec theta. Now, which trigonometric functions are positive in which quadrant? So that is quadrant positive trigonometric functions. Now this is our x-axis and this is our y-axis. So we have this Cartesian coordinate system here, and this is first quadrant, this is second quadrant, this is third quadrant, and this is the fourth quadrant, and we have the super hexagon here. So remember, in the first quadrant all the trigonometric functions are positive. In the second quadrant, so we will start from here in this super hexagon. I will write down this as a second quadrant. So in second quadrant, sine and its reciprocal, that is sine and cosec, they are positive. All remaining functions are negative. In the third quadrant, so here we have the third quadrant, tan of theta and its reciprocal, they are positive, and all remaining trigonometric functions are negative. And in the fourth quadrant, we have cos of theta and its reciprocal, that is sec of theta, are positive, and all other trigonometric functions are negative. Now to remember this, there is an easy way, that is just remember add sugar to coffee. So just remember add sugar to coffee. So A means all. So here all trigonometric functions are positive in first quadrant. Then S means sine and its reciprocal, that is sine and cosec. So only sine and cosec are positive in second quadrant, all remaining are negative. Then T means tan and cot are positive in the third quadrant, all remaining are negative. And coffee, so here C means cos and sec are positive and all remaining are negative. So just remember, add sugar to coffee to remember this in an easy way. Your support is motivation for making such videos. So do like, subscribe, share, comment, press bell icon. Thank you very much.